Hello ma'am, hello everyone. So we are now in the lecture 4, series and parallel circuits. So problem set number 1, example 10.2, equivalent resistance, current and powers in a series circuits. So in this problem, our givens first is this a series circuits, and this series circuits has 9 volts and has 420 ohms and 110 ohms. So in this problem we're going to solve for the equivalent resistance, second the current, third is the potential drop, and D is the power dissipated in the power source. So first, so letter A, in a series circuit the equivalent resistance is the algebraic sum of the resistance. So the equivalent resistance is the algebraic sum of the resistance. So um, equivalent resistance is equals to R1 or resistance 1 plus R2 plus R3 plus R4 plus R5. So 20 ohms plus 20 ohms plus 20 ohms plus 20 ohms plus 10 ohms is equals to 90 ohms. So our equivalent resistance is equals to 90 ohms. Second, for let's solve for the current. So the current through the circuit can be found from Ohm's law and is equal to the voltage divided by the equivalent resistance. So current is equals to voltage divided by the equivalent resistance. So voltage given is 9 volts divided by the equivalent resistance, which is 90 ohms. So the current is equals to 0.1 amperes. Now for the potential drop. So the potential drop across each resistor can be found using Ohm's law. So um, volt 1 is equals to V2 is equals to V3 is equals to V4 is equals to 0.1 amperes times 20 ohms is equals to 2 volts. And for the um, V5 is equals to 0.1 amperes times 2, 10 volts, so is equals to 1 volt. Now V1 plus V2 plus V3 plus V4 plus V5 is equals to 9 volts. Since kanan siya ang V1 to V4 is same naman siya ng ohms, so giisa lang na siya. So 2 volts, and sa V5 since isa ra siya nga 10 ohms, so 0.1 amperes times 10 ohms equals to 1 volt. So that's why 9 volts ang And for the power dissipated by a resistor is equals to P times equals to I squared R, and the power supplied by the battery is equals to pi is equals to power is equals to current times E, or the volt. So P1 is equals to P2 is equals to P3 is equals to P4 is equals to 0.1 amperes squared times 20 ohms is equals to 0.2 watt. So P5 is equals to 0.1 ampere squared times 10 ohm is equals to 0.1 watt. And for the power dissipated is equals to 0.2 watt plus 0.2 watt plus 0.2 watt plus 0.2 watt plus 0.1 watt is equals to 0.9 watt. And for the power source is equals to current is equals times the volts is equals to 0.1 ampere times 9 volt is equals to 0.9 watt. Problem set number 2, example 10.3, analysis of parallel circuit. So in this problem, the given in this problem is this is a parallel circuit, and the first resistor is equal to 1 ohm, second resistor is equal to 2 ohm, the third resistor is equals to 2 ohms, and the voltage is 3 volts. And in this problem we're going to find the equivalent resistance, the current supplied, current in each resistors, the power dissipated, and the power output. So first, The total resistance for a parallel combination of resistor is found using um, the equivalent resistor is equals to the summation of 1 over R I raised to negative 1. So um, equivalent resistance equals to 1 over R1 plus 1 over R2 plus 1 over R3 raised to negative 1. So substitute the value of the resistors is equals to 1 over 1 ohm plus 1 over 2 ohms plus 1 over 2 ohm raised to negative 1. So the equivalent resistance is equals to 0.50 ohm. So second, for the current supply, the total current can be found from Ohm's law, substituting equivalent resistance for the total resistance. So I is equals to volts divided by the equivalent resistance. So volts is given, which is 3 volts, and um, the the equivalent resistance is equals to 0.50. So 3 volts divided by 0.50 ohms is equals to 6 ampere. And for the current for each resistor, so the individual currents are easily calculated from Ohm's law, since each resistor gets the full voltage. So for the first current, so current is equals to V divided by resistor. So for the first current, V divided by the first resistor, which is 3 volts divided by 1 ohm is equals to 3 ampere. Second current is equals to V divided by the second resistor, which is equals to 3 volts divided by 2 ohms equals to 1.50 ampere. And for the third current, volts divided by the third resistor, so 6 volts divided by 2 ohms equals to 1.50 ampere. So the total current is the sum of the individual currents. Current 1, current 2 plus current 3 is equals to 6 ampere. Letter D. The power dissipated by each resistor can be found using any of the equations relating power to current, voltage, and resistance. Since three are known, let us use P is equals to V squared divided by R, since each resistor gets full voltage. So power 1 is equals to V squared divided by first resistor is equals to 3 3 volts squared is equals I divided by 1 ohm is equals to 9 watt. For the second power, for the P2 is equals to V squared divided by the second resistor is equals to 3 volts squared divided by 2 ohm is equals to 450 watt. P3 is equals to V2 divided by third resistor is equals to 3 volts squared divided by 2 ohm is equals to 4.50 watt. And last, for the total power can also be calculated in several ways. Choosing power is equals to current times volts is and entering the total current yields to P is equals to I times V is equals to 6 ampere times 3 volts is equals to 18 watt. Total power dissipated by the resistor is also 18 watt. So P1 plus P2 plus P3 is equals to 9 watt plus 450 watt plus 450 watt is equals to 18 watt. Problem set 3. Example 10.6. Calculating current by using Kirchhoff's rules. Find current flowing in the circuit in figure 10.29. So the given is the figure 10.29, and in this problem we're going to find the current. So this circuit is sufficiently complex that the current cannot be found using Ohm's law. In the series parallel techniques, it is necessary to use Kirchhoff's rules. Current have labeled current 1, current 2, and current 3 in the figure, and assumptions have been made about their directions. Location on the diagram have been labeled with letter A through H. In the solution, we apply the junction and loop rules, seeking three independent equations to allow us to solve for the three unknown currents. So first, Apply the junction and loop rules yields the following three equations. We have three unknowns, so three equations are required. So junction C, I1 or current 1 plus I2 is equals to I3. And loop ABCDEFA, I1 times R1 plus R4 minus I2 times R2 plus R5 plus R6 is equals to V1 minus V3. And loop CDEFC, I2 times R2 plus R5 plus R6 plus I3 R3 is equals to V2 plus V3. Simplify the equations by placing the unknowns on one side of the equation. So just junction C, I1 plus I2 minus I3 is equals to 0. And loop ABCDEFA, I1 times 3 ohm minus I2 8 ohms is equals to 0.5 volts minus 2.30 volts. And loop CDEFC, I2 times 8 ohms plus I3 1 ohms is equals to 0.6 volts plus 2.30 volts. Now simplify the equations. The first loop equation can be simplified by dividing both sides by 3. The second loop equation can be simplified by dividing both sides by 6. So junction C, I1 plus I2 is minus I3 is equal to 0. Loop ABCDEF A, I1 is 3 ohms minus I2 8 ohms is equals to negative 1.8 volts. For loop CDEFC, I2 times 8 ohms plus I3 1 ohm is equals to 2.9 volts. So the results are the current 1 is equals to 0.20 ampere, current 2 is equals to 0.30 ampere, and for the current 3 is equals to 0.50 ampere. Problem set 4. Example 10.7. Calculating current by using Kirchhoff's rules. Find the current flowing in the circuit in figure 10.30. So the given is the figure 10.30, and we're going to find again the current. So this circuit can be analyzed using Kirchhoff's rules. There is only one loop and no nodes. Choose the direction of current flow. For this example, we will use the clockwise direction from point A to point B. Consider loop ABCDA and use figure 10.23 to write the loop equation. Note that according to figure 10.23, battery V1 will be added and battery V2 will be subtracted. So, applying the junction rule yields the following three equations. We have one unknown, so one equation is required. So, loop ABCDA, negative IR1 minus V1 minus IR2 plus V2 minus IR3 is equal to 0. Simplify the equation by placing the unknown on one side of the equation. So use the values given in the figure. So I times R1 plus R2 plus R3 is equals to V2 minus V1. So I is equals to V2 minus V1 divided by R1 plus R2 plus R3 is equals to 24 volts minus 12 volts divided by 10 ohms plus 30 ohms plus 10 ohms is equals to 0.20 ampere. So the current is equals to 0.20 ampere.